My topic is Napier's bones. So here's a general outline of what I will be reviewing today. But first, in order to understand the tool Napier's bones, it's important to understand the person who invented them, who is John Napier, and the circumstances that led him to invent this tool. So John Napier was born over 450 years ago in Edinburgh, Scotland. He was an avid Protestant and was engaged in ongoing dissent with the Roman Catholic Church, and he also pursued mathematics on the side. And apart from Napier's bones, his most famous invention in the field of mathematics was logarithms. In the early 1600s, astronomy and navigation were key areas for advancing both politics and religion. Both of these fields required advanced calculations, and in the absence of iPhones, multiplying numbers was one of the elements that took time. Given Napier's devout nature, he saw that these time-consuming calculations were slowing down the advancement of the Protestant belief, specifically due to the time they took for astronomers and navigators, and he sought to create a fix. His solution was the system called Napier's rods, or as they are more commonly known, Napier's bones. As you can see in this picture, Napier's bones is just a set of wooden rods with numbers on them. So essentially, Napier's bones helped break down a multiplication problem into multiple smaller addition problems by utilizing partial products. This system allowed for the quick multiplication of any two numbers. So in each set, there are 10 rods, a 1 rod, 2 rod, 3 rod, 4 rod, and so on. The 0 rod is not shown in this illustration, as well as a special 11th rod, which is the multiplier rod, shown in red here. And the 8 numbers in each rod below the topmost number are basically multiplication tables between the topmost number and the digits in the multiplier rod. So, for example, 1 times 2 is 2, 1 times 3 is 3, 1 times 4 is 4, and so on. And as the products get into multi-digits, each square is split diagonally with a diagonal line from the bottom left of each square to the top right of each square so that each digit is represented separately. And Napier published this system of Napier's rods in a book called Rhabdologia, which translates to collection of rods. So an example, we can multiply 4,138 by 567, and how we would do this but with Napier's rods, we would first arrange the four rods 4, 1, 3, 8 in this order from left to right beside each other, and we would then place the multiplier rod adjacent and to the right of these rods. We would look at what are the digits in our multiplier, which are 5, 6, and 7. So we would isolate the 5, 6, and 7 digits in the multiplier rod, as we will only be working with these rows. And we start with the first digit 5, and we work from right to left in this row. So first we have the number 0 here. We record that down. We write that down, 0. We go across the diagonal line, and we add up the next two numbers between the next two diagonal lines, which are 5 and 4. So 5 plus 4 is 9. We record that down, so we have 9 and 0 so far. We go across again, 5 plus 1 is 6. We go across, 0 plus 0 is 0, and we go across, we just have 2, so we write down 2. And we're left with the resulting partial product, 20,690. And we repeat the same step for the next two digits in the multiplier, 6 and 7, to get 24,828 and 28,966. And we finally add up these three partial products and make sure to arrange them when we're adding them up using the partial product of the second digit is arranged one digit to the right when we're adding them up. So its leftmost digit is aligned one to the right of the leftmost digit of the first partial product. And we continue doing this for however many digits we have in our multiplier. So our partial product for 7 is 2 digits to the right. And adding them up, we get the final answer, 2,346,246, which is our final product. So impacts of Napier's bones. Apart from the significant impact Napier's bones had on the mathematical fields of astrology and navigation, it also led to a greater understanding of how arithmetic operations can be simplified through mechanical means, and this principle is still being taught to young children today. Napier's bones were also directly inspired by Napier's logarithms, which Napier developed a few years earlier. These logarithms simplified multiplication and division into the simpler operations addition and subtraction. And Napier's bones were a precursor to the slide rule, which was the first mechanical calculator, which eventually led to more complex calculators in the future. So always remember what is written on this shirt. Rhabdology is cool, and thank you.